Inequalities is one of these things which takes from the algebra that you've already done. So that's why I thought, Pat, you'll be fine because you've done so much work on algebra and you're so good at it now that it shouldn't really be a problem. There's just one slight change. Okay. Let me just recap something though. So if I said to you x plus 4, so rather than write anything, just focus on me at the moment. We can write it afterwards. All right. If I said x plus 4, that is called a what? Good. It's an expression. Do you remember that? Because there's stuff in your test about write an expression for blah blah blah. Okay. If I said to you equals 7, that turns it into an equation. An equation. I want you to see the word. So, an equation. Okay? And you notice how the equation, that is like saying it equals a value, yeah? Do you see that? Alright. So if I said to you, solve that equation, what would you tell me the answer was? What is 3?
X equals 3.
Right. X equals 3. And this is the thing. So that is solving an equation. And what have I done there? What are you, in language, what are you telling me? That x equals 3. What does it say?
With minus 4 from both sides.
Not what am I doing, but what is it telling? Okay, that's what I'm saying. 3 plus 4 equals 7. Could x be anything else other than 3? No. Why?
Because only 3 plus 4 makes 7.
Only 3 plus 4 makes 7. That's it. Just one value for x. Does that make sense? So, this is where I'm going to change it from an equation to an inequality. Let me just rewrite that so you can see again. Now this is an inequality. Okay? Now do you notice how the equal sign is still there? Right? But we've got this extra bit of inequality. Now we still have a value, but if I change this equation, so this is an equation, I'm now going to write an inequality in the same way. And I'm going to write x plus 4, okay, and I'm going to write this symbol. Do you recognise it?
Greater than.
Well, what does, read that to me.
X plus 4 is less than 7.
Yeah, so x plus 4 has to be less than 7.
Because the alligator eats the bigger one.
Okay, the alligator eats the bigger one. Now, what does that mean about my x value? Is x equals 3 still the only possible answer?
No.
Why?
Because it says anything smaller than, I mean anything.
It's not equals to.
It's not equals to 7, it's
Has to be less than.
has to be less than 7. So how many values for x can you choose?
Anything that
1
equals
until
less than
7.
7.
Well, how many values of x are there going to be?
A lot.
A lot. How many exactly, do you know?
Because they
Didn't
can
include
Okay, so negative numbers.
Negative numbers, decimals, so there's actually an infinite number of numbers, yeah? Right? So this x equals 3 is not going to be right.
Infinite, would you have to put like an infinite?
Well, what we actually say is this. We say x has to be less than 3. Does that make sense?
But
Not really?
yeah, because then if it's anything bigger than 3, then it would equal over 7, and it has to be smaller than 7.
Yeah. So, does that make sense? So if I pick a value less than 3 for x, x plus 4 will be less than 7.
Yeah, but if it's anything bigger than 3, like 4, then it'll be 8. Just bigger.
Yeah.
Wait, so you just have to
before you write, let's have this discussion just a bit more. So, what the thing is, this x minus 3 represents how many numbers? No. We already said it once. An infinite number of numbers. How many numbers are there less than 3? An infinite number. There's decimals and negatives, and you've already told me that. So what I'm saying here, so this is my equation. Again, I'll let you write in a sec. Just focus, try and get your head focused on it. This, although it looks exactly the same thing, this is an inequality. Okay? And basically what we're saying is that, well, if x plus 4 has to be less than 7, well, x can be anything less than 3. So that's what this means. X can be any value less than 3.
Wait, so you have to solve it by an equation and then you have to...
Yeah, exactly. That's what people do. Do you want to write it now? This one, I would say x can only be 3. But the inequality, x can be any value less than 3. So let me give you another example. So for instance, have you written that? Can I?
Yeah.
So what you might see is solve the inequality. Okay. Should we say 2x minus 5 equals 9. That's alright. That's not an inequality because I put an equals. I'm going to put this.
Oh, so it's greater than.
So I'm saying solve the inequality. 2x minus 5 is greater than.
9.
What about the good? What's the double line for?
Yeah, that's right.
What do you think it means? Let me redraw it.
Greater than or equals?
Yeah, exactly. So that on its own means greater than. If I stuck a second line, it means and equal to. You see that bit looks like an equal sign on its own. So what I'm asking you is, what values of x can I use
Wait, so this
so that 2x minus 5 is less than or equal to 9? That's what I'm asking you for. Solve the inequality. So, any ideas what you would do?
Would you solve it first?
Oh, go on then. Give me your method. What would you do?
So you do 2x plus the 5 on both
So I'm going to
sides.
add the 5, like you would do if it was an equals.
So then you do 2x is greater than or equals to 14.
Yeah.
And then you divide, and then x is greater than or equals to 7.
Okay.
Is that actually?
That's it, isn't it? So it's exactly what you've been doing before, yeah? But with a different symbol. But what I would say is, let's check.
So what does that symbol mean?
What symbol?
This one. Does it mean less than or equal or more than or equal?
It means both, depending on which way you read it. So this here, if I were to read this, I would be saying x is greater than or equal to 7. But if I read it the other way round, it'd be 7 is less than or equal to x. Because that's the thing with maths reading, you don't have to read left to right, do you?
Yeah.
You can read in left to right, right to left, however you like. Alright? But when I say let's check, what do I mean?
To see if it works.
To see if it works. So what we've got is we're saying for 2x minus 5 to be greater than or equal to 9, x has to be a number greater than or equal to 7. So what would it make sense? Let's check with x equals what?
7? Wait, no.
That would be but that would be equal to, yeah, we could do it in this case. But normally, because x has to be greater than or equal to 7,
So you could do 8.
I'd pick a nice easy one. But yeah, 8. Let's check with x equals 8. So there we're saying that 2 times 8 minus 5 should be greater than or equal to 9. And we just do a check. And we say, well, that's 16 minus 5 should be greater than or equal to 9. Well, that's 11 should be greater than or equal to 9. And is that true?
Yeah.
It is. 11 is greater than 9, so I'm fine. Assuming I didn't make any mistake with my calculating of 7, it should be fine. So with these inequalities, it's always a good thing to check. Can I give you one to do for yourself? Okay. So if I say solve the inequality, 3 times 2x minus 1 is less than, what should I do? 15. Okay, have a go at solving that for me.
And it doesn't work.
Well, let's see, what did you do? So how did you do this?
I did 6x
So you all expanded, I saw that, yeah? You did 6x.
minus 3 is less than 15.
See, that's one way. I'm just going to write over here, look, just so you've got a different way. I actually divided by 3 first. So if I divide, because it's 3 times, so if I divide by 3, I get 2x minus 1 is less than 5. But you didn't have to, you can do that way. What did you do after this?
Plus 3.
Plus 3, we get 6x is less than 18.
And then divide by 6.
Divide by 6 gives you 1x is less than
3.
3. So, we'll just check it. What value did you pick, Moran? What value did you check with? You said it didn't work.
3.
But then it's got to be less than 3. You can't use 3 if it's got to be less than 3.
I used 2.
Yeah,
2 works. I mean, actually, the easiest one for x is less than 3 is 0, because that's really easy to work with. But 2's fine. So if I were to check with 2, I would get 3 times 2 times 2 minus 1 should be less than 15. So that's 3 times 4 minus 1 is 3.
Oh, yes.
Yeah, 4 minus 1 makes 3.
Oh, yeah, that's a fast one.
Yeah.
And then 9, yeah.
So 9 should
Yeah.
be less than 15, which it is, so we're fine.
I did try
Yeah,
to
decimals work as well.
I thought it would.
What about this one? The next one then?
Oh, wait, I have it first.
Oh.
We do 2x divided by 3. Right, just in case you're watching at home. Okay, times by 3 first, because we've got to divide by 3. So we end up with
2x is greater than 12.
Okay.
And then
Wait,
you
why
Can I just ask, this is what Taylor and I were talking about, and lots of people have done this in the past. They would write this down. What have they done?
Oh, they times the 2 by 3.
Well, yeah, see, what they do is, this happens regularly, is they know they've got to times by 3, because it's divide by 3, but then they say, oh, well, that makes 6x, because it's times by 3. Why is it not 6x? Why is it only 2x? Can you explain?
I'm just trying to get rid of the divide
Exactly.
Yeah.
That's it, isn't it? I've got 2x's divided by 3 gives me 4. So do you remember what I said with the language? You say, well, what did I have before I divided by 3?
At a time.
Well, I only had 2x's, and on the other side must have been 12. So I didn't have 6x, I had 2x's. And what do we do now? So I've got 2x's, mate.
So you divide 2 by both
So
sides.
now we divide 2 on both sides, and I get...
X is greater than 6.
Okay. And if I wanted to do my check, so Abby, do you get this now? So what would you use to check? So check with x equals... Well, what do I want? I want an x value that is greater than 6. So 8, okay? I'm going to check and say, right, so if that's true, if I'm right with that, is it that or is it that? That's the question. Have I got it right or have I got it wrong? So I'm going to check. So therefore, 2 times 8, I don't know why I said 18, 2 times 8
Over.
divided by 3 should be greater than 4.
So then you can do 16 over 3.
16 over 3 should be greater than 4.
Which
Now, I've not picked a very nice number, but how do I know I'm correct without having to work out decimal? Well, because I know that 16 divided by 4 is 4,
Oh yeah.
so 16 divided by 3 is going to be more than 4. So that's it. That's all I need. That's my argument. I'm done. I'm right, so...
You don't have to change to decimal.
Pardon?
You don't need to change to decimal.
No, we just need to know if I'm right. I know that 16 divided by 3 is bigger than 4. That's it. Yeah?
And 3 times 5 is 15. So if you have to go further, then that means that
That's another one, isn't it? Yeah.
because if
Girls, did you get that? Good argument. 15 divided by 3
is 5.
is 5.
Yeah.
So 16 divided by 3 is going to be
more than
even more, you know. So there's another argument. That's a good argument as well. So we're right. Okay? Now there's another thing I'm going to add in. And I'm going back to the beginning. Okay? I've solved my inequality. But I'm going to show my answer on a number line. So, for instance, I'm just going to show, I've not got much room. I should have left myself a bit of room because I knew I was going to do this. But this is how I do it. So if I've got a number line, my number line could look something like this. So I can put 0, 1, 2, 3, and I might put -1, -2. Are you happy with that as a number line? Okay. Now I've got to show on my number line that x is going to be less than 3. Any ideas? Well, I'll tell you what, I'm going to do 2 of them, and I want you to see whether you can work out what I'm doing and what's different. So this one, I'm saying x has to be less than 3, so I'm going to do this. Don't draw this yet, because you might not pick up on it and you might do something wrong. So I am going to, x has got to be less than 3, so this is good. I'm going to do this, and then I am going to draw that way. Okay? Does that make sense?
What's the 0 for?
Okay, it's not a 0. And let me say why. So, have you got that one? I'll let you draw it again in the middle. So, think about what I've done there. Think about what I'm saying. X has to be less than 3. This one, x has to be greater than or equal to 7. So this time, I'm going to cut it down a little bit. And here's my number line, and I'm just going to draw. I'm going to put a 7. I could, if I like, put 8, 9, and this time, let's do that. Let's do my arrow going. That makes sense. But there's one thing extra I'm going to do. I'm going to do this.
Yeah, to make it so equal and
So what do you think the difference is? So you said a 0, but it's not a 0.
It's like the mark.
Wait, I'm confused. What is
And
this?
for that one, there's
Percent.
no, you can't write 6, 5, 4, 0.
You can,
Oh, actually,
Wait,
but why haven't I bothered?
because it's great.
Because it's greater than, yeah. So I've just put the smallest. Now, what you might find, for instance, you might be given a number line that starts at 1 and goes to 10, and you just have to use it. Sometimes you just have to draw your own, and then I only need that. So, for instance, before you draw those, let me just do this next one then. So I've got, what do we have as the answer? X has to be less than 3. So if I did my number line here, okay, I'm just going to put a line, and what am I going to write under it?
3.
3.
Yeah.
I'm going to put a circle.
And then you're gonna go.
Am I going to fill it in or not fill it in?
Not fill it in.
Not fill it in because
You're going
It's
down.
not equal.
it's not equal to. And which way does my arrow go? That way or that way?
To the left.
To the left, because I go left. And actually I don't need any more numbers. I can just put the 3.
Oh.
I don't need to draw anymore because I know to the left is smaller than 3 because it's a number line. Okay? So do you want to do number lines for all of yours so you can go back to what we did
So
to start
if
with?
it's, if it's
If it's equal to, it's a solid dot.
okay.
If it's not equal to, it's an open dot. Okay? Okay, so this is an example of one that you might think is a challenging
Yep.
algebra solve. So imagine, for instance, if I said that was just an equals sign, that would make it an equation, and you would know what to do. What are you going to do? Expand the brackets,
And then
collect the like terms, and solve with an equals. But instead of an equals, I'm just going to put an less than or equal to sign.
Are we also supposed to do the?
And then I want you to show me your answer on a number line. Okay? Talk me through it. What do we do? Or do we have to expand the brackets first?
Oh.
Yeah. So what are the brackets expanded? 4x take away 2.
And then the other one is negative 3x take away 6.
Okay. That has to be less than minus 7. Collect the terms. So it's 4x's minus 3x's is,
I thought it was x.
it is x, you're right, your thoughts were right. What's minus 2
I think I got it wrong.
minus 6?
Oh.
8? Minus 8?
Minus 8, good. Minus 8 is less than, and this I think is where your mistake was. Maybe, or did you have plus 8 there?
Yeah, I did plus 8.
Yeah, okay, so that's, and 2 minuses don't make a plus, do they? In
Oh,
that
no,
case?
I did x take away 8.
Okay, it's minus 7, right? So this must be where you made a mistake then. What do we do now?
I added 8 to the
Yeah, add 8 to both sides. X therefore, what's it? Negative 7, add 8.
Negative 1.
One.
It's
Oh,
just
is
one.
it just
Just
It's
one.
just 1, isn't it? So you were thinking 7 and 8 with a negative, weren't you?
Yeah.
7 add 8 makes 15 with a negative, negative 15, but it's not. We're at negative 7, we add 8 to get to 1.
So we can test with a negative number?
You can, yeah. If I would check, I would actually check with x equals 0. It's quite a nice one. You check
But I
that.
got it
But you
wrong.
could use a negative. So should we just check with 0?
Yeah.
So I'm just going to rewrite all this out and say it's 2 times 2 times 0. That's that bit. Minus 1 minus 3 times 0 plus 2. So that 0 is where this x was, yeah? You got that? So I've substituted my value in that's less than 1. So what do I get? So I'm going to do the brackets first. So I've got 2 times, what's 2 times 0 is? 0 minus 1 is? Negative 1. And then I've got minus 3 times 0 plus 2 is? 2. All of that at the moment should be less than or equal to minus 7, if I'm correct. So what's 2 times minus 1? Minus 2. Minus 3 times 2 is 6. Should be less than or equal to minus 7. What's minus 2? Subtract another 6.
Minus 8, which was already there.
Minus 8, which is less than or equal to?
Minus 7.
Is that correct?
No.
No.
Why?
Because it's more.
Wait, actually, yes, it is.
Oh,
yeah.
It is, isn't it? Exactly, negative numbers, isn't it?
Oh.
Negative 8 is less than negative 7. What's your proof? You got any context to put it, to argue that with someone?
No.
How do you know that minus 8 is less than minus 7?
Because you need to plus
It's
1.
further from the positive.
It's
It's
further
further
from
from
the
the zero.
positives, yeah. If you think temperature, which one's the lower temperature? Negative 8 is colder than negative 7, yeah. How do we then show that? So I've got, this is my answer. X has to be less than 1. How do I show that on my number line then?
So you do 1.
So there's my line. I put a line there in the middle, put a 1. And then you would do?
Wait,
So you
what?
do 1 and then the circle thing with the
Fill it in.
fill it in. Yeah.
Fill it in.
And then you go to the left.
And we go X has to be less than that. So go that way. Cool. Perfect.
Wait, what would it be? Okay, never mind.
Happy with that?
Mm-hmm.
Should we just do a couple of checking algebra stuff for your exam?
Oh, so not inequality.
So are you happy with inequalities or do you want another one?
No.
Another one.
We have one more.
One more, okay, I'll give you one more. Let me do something like, hey, killing you with it. What about,
Sorry.
Make it easy.
x,
Make it hard.
2x minus 5, all divided by, what should I say,
3,
2
4.
equals, I'm not going to do equals because obviously that's not the right thing, is greater than or equal to 3.5.
Interesting. Mr. Plot.
Right, should we have a look then?
Right. Left.
What should we, no, it's to the right, yeah, you said is your arrow right. Should we go through it then? What's the first thing we do?
Times by 2.
Times it by 2, why?
To cancel out the division.
To cancel out the divide by 2. So I've got to times this side by 2 as well. That gives me
2x minus 5 is less than, is greater than or equal to 6. No, sorry, 7.
7. Alright? Then I
Oh, and then you add 5
add 5.
to both sides.
Gives me 2x.
2x is greater than or less or equal
That's
to
why I can't.
12. Then divide by 2.
Divide by 2, and we get x equals 6.
X
is greater than or equal to 6.
Okay, so you've done your checks. I'm not going to do it. I'm happy that you're right. So if I put on a number line and we do a 6 and it should be
A closed in circle.
closed dot
And arrow to the right.
and an arrow to the right.
Because it has to be greater than or equal to.
Okay. Sorted?
So when it has the dot, it means that it's equal to or greater than, but when it's a circle, it has to be less than or
No.
above.
No equal to when it's open.
Yeah, when it's open, it has to be less
Or more.
Yeah.
If it's closed in, you have the and equal to.
Less, more.
Right, inequalities are good. There is another type of inequality where you have limits on two ends. Do you want, I mean,
No.
you don't want to worry about that?
What do you mean, like oil?
No, no. So for instance, I think I took this one out. But if I said to you, let's just see whether I could put it back in. Let's see if it works. Let's say if I said x minus 5 has to be less than or equal to 7, but greater than minus 2.
What?
Oh,
Whoa.
yeah. Can we not? Can we not?
So this has got two limits.
Wait, I
Okay.
don't understand how to do that.
And this is what you would do here. You actually have to split it and you say, all right, well, let's find out where x minus 5 is less than or equal to 7 first. So what would it be? X has to be less than or equal to 12. And then we do this side and we say x minus 5 has to be greater than minus 2. So that makes x has to be greater than what?
Minus 7.
3. Well done, because we've added 5. Yeah. So now where we split it, we now combine it back together and we say, right, x has to be less than or equal to 12, but greater than 3.
Oh, and then you're
And that's it. And then we do our number line. Now what do you think this time with the number line?
You had two,
So I have a line here that says 3 and a line up here that says
so you do
12. What goes above this one?
a dot. No, a circle.
Yeah, circle.
And then this one?
A dot.
And this time we just, no arrow, just a line.
Well, that makes sense.
Because it's got to be between those 2 points.
Do you want to write this down?
I think I took this one out of
Okay.
your test.
Wait, this is the.
But it makes sense, right?
This is what they learned and they
Should we
understood.
write it down anymore?
Up to you. You can write it down. Why not add it to your notes? It'll be there for next year. Do you understand that bit of you split it? So
Yeah.
x minus 5 gets split, so you do it separately. And then it kind of, once you've worked out what x has to be, you bring it back to make 1x. Yeah? Well, moving on from inequalities, I just want to check a few things with you. Alright? So, x squared plus x squared plus x squared plus x squared simplifies to 4x squared. Good. W cubed times w cubed times w cubed is?
3W9.
Well done, TH. W to the power of 9.
Oh, yeah.
Yeah?
I was thinking.
Because plus is.
What about this one? 4y cubed squared.
So would it be?
4y
Would it be 8?
4y to the
Not
power
Would it be 8?
Not quite.
Oh, no.
wait. It would be
4y to the power of 5.
Would it be 10y?
You change the 4. It would be
Power of
8y
six?
to the power of 6.
No.
Would it
What
be
does squaring mean again?
Is it
Oh,
16y?
Oh yeah, 16y
16 y to the power of 6.
Wait, how?
Because what does squaring mean?
Oh.
double it.
So it's not double it, no. It means that times,
That times
Again.
itself.
yeah, which becomes 4 times y cubed times 4 times y cubed. Okay? Remember that? What if I said simplify? You shouldn't need to write these down as much. It's on the video. I'll put it up there. But these are notes you should already have. I'm just reminding you. What about if I said to you 5a cubed b times 3ab squared?
15. 15a.
B.
But what does this mean? It means
A squared.
5
No,
times
15a cubed B. No,
A cubed. A fourth.
8 to the power of 4, isn't it?
oh yeah.
And then
B
b
to
to
the
the
power
power
of
of 3.
3.
Oh.
Good.
Is
Oh right, because there's like an invisible one.
Yes, there's like a 1 there, isn't there? Got that? Make sense?
But it's kind of confusing because why would it be?
Yeah, that's weird.
Oh, no.
Well, it's like, I was just about to rewrite it out.
Wouldn't it be 4 then? If it
Because
was
it's
1?
5
Oh,
times
yeah,
A
just
times A times A times B times 3 times A times B times B.
Basically just.
So you just collect all the A's,
Oh,
so that's
yeah, because the b is
4.
2 of them. Okay.
B's, another B makes the 3.
And then, yeah.
I get
And
it.
5 times 3 is 15. Okay, I just thought of another one I wanted to say.
You have to
What
add it.
about 8x squared y over 2xy?
What do you want us to do? Simplify?
What does the
4.
over mean? Divide. So it's
4.
4.
4x.
X, yeah, and then it'll be y. 4xy.
No, not quite. Why is it not x squared anymore?
Because you divide by 2.
So we've divided by 1. The 8 divided by the
Oh, so
2.
it's just 4x.
So the y divided by the y also cancels, so we're left with just 4x. Done that before? We've done that before, haven't we? So for instance, if I said to you 18hg cubed over 2hg, sorry, h squared g I want, what would it be?
9.
9?
Oh.
Yeah, 9h.
No, no.
Wait.
So where's the h left? So that h divides with this one. So actually we still have a h on the bottom.
Oh, that makes sense.
Oh.
9h and then g at g squared.
Yeah.
Oh, that makes sense.
Yeah?
Oh yeah.
Sort of? Because this divide by h twice, h times h,
Yeah, because
only
there are
gets
2
rid of-
h's.
so only one of them is used, yeah? So we've still got a divide by h. Does that make sense? You're looking at it a bit weird. Because what this is 18 times h times g times g times g, but then divide by 2, divide by h, divide by g. Oh, actually, there should have been another h in there. Divide by a second h, and then divide by a g. Alright? So that's what we had to start with. Alright? So what happens? So the 18 divided by the 2 gives me the 9. 1h divided by a h, well that goes. And then 1g is divided. So what am I left with? I'm left with the 9, which was there, the 2g, the g squared, and then the divide by h is still there. Make sense? Right, something for you to prepare for. Tomorrow we're going to talk about percentages. How to, I know we've done this a bit, how to increase and decrease by a percentage. So for instance, if I said to you, increase 20 by 12%, remember how to do that?
No.
Not at all. Okay, so we're going to do that. So if you fancy having a look at how do I find Do you know how to find 12% of something?
I forget.
You forget. Well, if you can find any notes that you've already got on how to find a percentage, we'll go through it because that's in the test. But do you remember when I said, let me just